So it's nice to be here again. I was actually speaking here 5 years ago, so a long time ago. So since then, I built a couple of different tools. This is what I'm mostly known for. Sorcery is one of them, but I have a lot of open source, a little too much to maintain, so I rely on the community of other iOS developers to help me with that. So you probably use some of them, otherwise you wouldn't be here. So what is Sorcery? Sorcery is a tool that scans your source code, that builds abstract syntax tree from your type information, and then it sends that information to your templates and generates more code or anything else, really. So it's a meta-programming technique that allows you to generate more code from existing code. Very simple. It's an application. It's not a framework that you include. It's not a code dependency. It's more like a preprocessor. So this works really nicely. You have to understand what templates are first, because that is how you define what is supposed to be generated from the code that you own. And Sorcery, basically, having the AST, it has to feed it somewhere to some kind of source code that generates more information from it. And if you ever used HTML or any kind of web frameworks, you probably work with templating languages like ERB in Ruby, or there's just a bunch of them. Like Effective JavaScript is one of them. And we support that along with Stencil and custom one, which is Swift-based templates. Effective JavaScript is the third one, which isn't as commonly used as the other two. They're all very similar. Sorcery is very modular, so you can bring more templating languages very easily, but those three should suffice for anyone, really. And this is how a sample template can look like. So for example, Stencil is a language that was built based on Swift. So it was made so it's very similar to Swift, so people have very little learning curve. It's created by Kyle Fuller. And this is the only one of the three that is not Turing complete, which means you cannot do everything with it that you can with normal programming languages. But it's the one that we recommend for beginners because it's very simple to read and simple to understand. Swift is basically real Swift, except we introduce a couple of tags that you can use, so the printing is easier. Because at the end of the day, what templates do is they allow you to enter and print statements in a readable manner. So what happens with Swift templates is we actually extract all of the code inside of the tags and we generate real Swift code. And from that code, we run that file through normal Swift compiler, which means this is slow, as Swift is, unfortunately. Effective JavaScript is Turing complete. It's full JavaScript language, but it's not compiled, which means it's very fast to execute as well. And as you can see, the differences between the three languages are mostly in tags. So it's very, very easy to use either one of them. And when you want to work with Sorcery, you need to understand some of the base features that Sorcery has. First off, it's not homegrown solution. This is all powered by Apple's own SourceKit, which means we don't have to catch up to Swift changing very often. We actually rely on Apple updating their own tooling, because SourceKit is what powers up Apple tooling right now. So Xcode and all this stuff requires SourceKit to be up to date. So Apple keeps it up to date, and because of that, we benefit from it. But SourceKit doesn't actually give you all the information that you might be interested in for code generation. So on top of SourceKit, we build our own parsing. We extract extra information from the types. But this is very limited, which makes it easy for us to maintain. For example, we scan, like SourceKit didn't used to give you the associated names of your enumerations, so the arguments wouldn't have the name. So we needed that for proper code generation, so we added a simple parser on top of that. And we do it for a couple of different things, like generics and a few other features. And the thing with Sorcery is it's not opinionated what it generates. It doesn't tell you how the output should look like. It can be Swift code, it can be Objective-C, you can generate Objective-C from Swift, you can generate documentation, you can generate dot files, so the graph files. It doesn't rely on any runtime. There is no magic involved in Sorcery at all because it runs as a preprocessor tool. So it actually generates all the code before it gets compiled. So all the code it generates will be regular Swift code that you will be able to debug, put a breakpoint in, and just as any code that you would write normally. And it's because of that it's compiled. So you don't have problem generating errors. If your templates are wrong, you can just fail the build. And it's typed, obviously, as Swift is. What's really nice about it, it enables real-time programming of your templates. What I mean by that is when you type code, you can see the results of that code immediately. So it makes it very easy to learn how to write templates. Unlike Swift, when you write code, you have to compile, and only then you can see whether your code worked. Here, you just save file, and when you save file, you see what actually produced. So it can be used, like I said, not for just code generation, but for example, for introspection. So here I'm inspecting New York Times code base, which was a few years ago when I recorded this originally. It's even bigger now. But you can see that it lets me understand what kind of types this project consists of, which is useful. I do a lot of code reviews for different companies because I'm a consultant. And this is usually how I start. I want to see whether people are using value types, whether they're using reference types. That already tells me some information about the project. What's really nice about Sorcery is it's not just reading your code, it actually allows you to attribute it. So if you ever work with languages like Rust or Java, you know that there are code attribution. So you can add to types or variables, you can add extra information on top of the type system. And that information can be things like, okay, I don't want to have this variable in equality, or this variable should be persisted as a different name under JSON parsing. So Sorcery adds support for that, and you just have to add a comment with Sorcery : basically, which is very convenient because it allows you to tweak the code that it generates in your template. And it also supports inline code generation. Because by default, when we generate code from Sorcery, we would create a separate file and we would create extensions for your types and add the code there, which is fine for 95% of cases. But if you have things like required initializers, for example, in Swift, those things cannot be defined outside of the type definition. So NS coding, for example, you have to have the initializer with the coder inside of your class definition. This is where inline code generation comes handy. And it's really simple to use. Basically, in your template, you just add a markup for the type name, and then you can use either auto or explicit. Explicit means you have to add the marker in your code as well. Auto means that if it encounters code like this, it will automatically add the code generated in the template at the end of your type definition, which makes it a little easier. So it really depends whether you want to control where the code enters. For example, maybe you want the inline code to be on top of your type before your actual implementation. Or if you don't, then you can just have it at the end. So this is very useful. So how do you integrate Sorcery? It's very simple. You basically, similarly how you have the build phases for like Swift Gen, Swift format, you add a build phase for Sorcery. That build phase should appear before the Swift compilation, otherwise you wouldn't have the code yet to compile. And Sorcery also comes in bundled with a lot of templates. And when you work on the new templates, you definitely want to use the daemon mode I just showed you. And is it gonna slow down your build? Because this is a big problem for us. Swift build times are known to be very slow and not very efficient. So Sorcery works with extremely fast parsing. Because of the requirements of this tool, it doesn't have to understand as much as Swift compiler does. Like Swift compiler has to understand all the files in your project and all the interdependencies in it, which makes parsing very complex. For Sorcery, the way it works, it can scan each file in your project separately, which means it's very easy to parallelize. All of the scanning happens on multi-threaded process. And then at the end, we combine the AST from all of those files into a single output. And we use extensive caching, because if each file can be scanned separately, we can also cache each file separately. So right now we rely on modified date. So if your file didn't change since the last time we scanned it, we just skip it and we just use the previous artifacts of that scanning, which is extremely fast. And the cost is negligible in comparison to Swift build times. For example, this is how long it took for the New York Times code base, and this is before I optimized it even more. It's less than a second for a massive project with almost 900 types. And so for most iOS projects, this is way, way faster. It's definitely not something you should be noticing in your daily work, and it's something that will save you a lot of time in a different situation. So how do we get into writing custom templates using Stencil? So there are a couple of things. So first off, this is how you render a variable. You just use the tag like this, and that will output a string that the variable contains, right? It will just basically do a description, how you would do in Swift. You can also introduce a local variables. So you can use the same code in multiple places in the template. So for that, you just do set, and then you specify variable name, and anything that goes between the set and end set tag will be a local variable for this name. So here I'm grabbing the argument, and I'm grabbing its name and then applying title case filter. So this pipe sign means that you're applying a filter. And similar how you do it in console, filters can be combined together. So you can have as many pipe operators as you want, and all of them, the next one always applies to the result of the previous one. So it allows you to pipe multiple changes. You can also create functions to reuse code. A function in Stencil is called macro. And so you specify the name of the function, and then you can specify as many arguments as you want. And everything between the macro and end macro tags will be a function. And then to call it, you just do call, the name of the macro, and then the list of arguments. And that allows you to reuse the code for your template. And this is very handy, especially when you do like very complex templates. You want to reuse the same logic, or you want to do recursion, for example. This is very handy. But you cannot write templates without understanding what kind of AST you are getting. So basically, abstract syntax tree is the meta information about every type in your project. So for example, you might be interested to find types implementing a specific protocol. So to make it easy, we built a DSL, which is basically just kind of dictionaries that we expose. And the main dictionary that you usually use is types. And then you can have types that implement a protocol name, types that inherit from a specific class. And when you have that, that returns an array. So if you do types implementing auto-initializable, that's a list, usually an array of multiple type ASTs. So from that, you might want to narrow it down because it's too vague. There is too many. You can have enums implementing a protocol, you can have classes implementing a protocol, and the code that you usually generate will be different for different scenarios. Like for example, equality, right? Equality implementation for enums is very different than equality implementation for structs. Because for enums, you need to access the associated values. For structs, you want to access the properties. So very different code. So how do you do it? When again, you use filters. So you use the pipe operator. So you can do any kind of array, and you can do pipe struct, and that will narrow down the list to just structures. So if you go types implementing protocol name, pipe struct, it will have an array of structures that implement that protocol, and it will skip all the enums. And you can also access the annotations that I mentioned before. So you can do if variable filter not annotated with skip persistence. So for every variable in my type that doesn't have the annotation added, do this logic. And annotated can be applied to arrays as well. So you could do types implementing protocol name, pipe struct, pipe not annotated, or pipe annotated something. So it allows you to very easily build up filtering in your templates. And you can also access the annotation values by just using the dot interface. So at the bottom here, you have variable.annotations.skipPersistence. And this is very handy, especially when you try to access keys. So let's say you want to do variable.annotations.json key for your codable implementation, or like JSON encoding. So it's really easy to access, it's really easy to define. So let's look at a couple of simple templates. So the first template, this is based on an article that I wrote. And the idea here is that every app has big dependencies in their you have big dependencies in your project. And those dependencies are usually singletons. So you have things like API client, an image provider, or an image cache, and like content coordinator, let's call it. And So I defined this container for those dependencies called app dependencies. But what I really want is I want to have a very easy to maintain dependency injection logic in my application, in my actors. So when I have to inject dependencies into a view controller, I want it to look like something like this. So I define in my view controller what kind of dependencies I have. And at dependencies, I want to define like, okay, so my dependencies is image provider and a network client. And I create a single variable that will have both of them. To be able to do that, I have to define has dependency protocol. And I also have to conform my app dependencies to that protocol. This is very simple. Like, I cannot go into detail here, but you can read my article. But this is very nice when you use things like routers or flow coordinators, because what this gives you is, in your flow coordinator, you can have the container for the dependencies. And then when you create a specific view controller, you always pass app dependencies. And what happens is the type system reads your type alias from your specific controller and only extracts those dependencies. So if in my code, I decide that I no longer need network client in my view controller, I just modify this single line. I just remove the network client here, and I don't touch anything else in my project. And the type system will automatically remove all the references to the network client. And so none of this code has to change at all, which is very convenient. But this is boilerplate, right? Because for every variable, I have to generate this, and then I have to generate conformance, which I don't like to do because I prefer to use automation. So how I do it, right? It's really simple. Basically, for every type that implements auto properties, so a normal loop, the same you would do in Swift, I'm gonna create a variable for the protocol name, because that I need protocol name twice. Obviously, I'm going to mark it so I can see from which dependency type I'm actually implementing the code, because I might have more than one container. And so now I go for each variable in my dependency type. So in the app dependencies, we had 3 variables. And for all of them, I want to create a new protocol, has dependency. And then I also will need to create an extension on the app dependencies to conform to that protocol, because it doesn't do it automatically. So here I define the variable, the protocol name, which is just the variable name, title cased, so it's more Swifty. And then I reuse that name to create the protocol. I use the variable name again, very simply, because that's how it's going to be accessed, and I reuse that very simply. So actual type name gets rid of type aliases, it just makes it more easier. And on the right, as you see, whenever I save the file, I see the results, which means creating a new template is extremely easy because you get immediate feedback. You don't have to wait for it. And then at the end, I just do an extension. And now I build a template that the only thing I have to do in my project is to attribute my containers with auto properties. And all of this boilerplate will be generated for me. Very simply, you see it's like a minute to type. So very useful. Another example might be using Sorcery to create DSL or change the way the developers have to define things. So for example, in the New York Times application, we have the concept of app events. This is not for analytics so much, it's more for like performance tracking. So what I want is, I want to make a system that makes it very easy for my developers, we have a lot of developers in different teams, to create new app events so they can track it. And so I don't want the developers to deal with introducing strings, building new functions. I want them to just define what is an event. So this is kind of like a declarative programming. So what the developers have is they have an app event, which is the main structure we have. And then in that app event, they can add cases with associated values. So an article load or item sized, which means that we just calculated the height of an object. And what I wanted to have is I wanted grouping. So the names are, it's not everything in a single app event. I want to have app event.sectionFront, app event.article.something, just so it's nicely typed. I don't want the developers to deal with how this data gets exposed to the servers. We're actually using Firebase Performance. Firebase requires you to use strings. That's why the types here are strings. So basically, whenever you add a new case or a sub-object, sub-enum, Sorcery will generate all the boilerplate on the bottom. And there is a lot more boilerplate in our app. But basically, it automatically extracts the variables, puts it into a dictionary of string to string, which is what Firebase requires. So all of this from just simple definition. And writing this is not very complicated. This is basically a template. So I have this. This works on a single, basically on a inline. So for each type, I will generate event convertible. And this is using inline, so it will inject that code into the previous definition instead of having an extension. And the way it's used is basically, so this is the definition of the macro. This is the main macro, which is called for every type. And how it works, right? So for each type that is passed as an argument from this definition doesn't fit the first for loop. Basically, this is for type implementing auto event convertible that are enums. That is what's missing in the projector. So then this is getting called for each of those types. So for each of those types, I define an extension for the name, and I conform it to event convertible, which is just regular protocol we have in the project. And then I have to generate two things. I have to generate the name function and the information, which is the dictionary. And the way it works, and then I also have to have recursion because I want to support the sub enumerations. So I just do recursive call to this function, which is very simple. Generating name is extremely straightforward. You just get the type, you just do the var.name, and it's a string. And if the case, basically you just grab the name without the associated value. So you just access the name. That's all, right? So if you have section front item size, it's gonna be app event.sectionfront.item size. That's the name of the event. The parameters are a little more complicated, but still simple. Basically, the way it works is you define a parameters variable, which has this type, which is basically a dictionary of strings. And then for each case, whether the case has associated values or not, you either return the first argument, which is just the first associated value, or nil if it doesn't have associated values. And that's pretty much it. It looks a bit more complicated because you have to deal with, you have three scenarios. You have no associated values, which means you return nil. You have one associated value, which means you just return that associated value. Or you have multiple ones, which means you have to build the whole dictionary. And that's pretty much it. I'm going to post it online. You can read it there. But it's pretty simple. And the other case we have is A/B tests. So in the past, we would have a lot of strings to write A/B tests. And I really disliked it. So I built a simple, basically the way this works is you have a simple generic, which is called test. And that is generalized over the enumeration of possible variants in your tests. So for example, here, I have a config source for the application. So I have a test that is config source. It has a unique key, and it has a default variant. So if I don't get data from the server, it's going to fall back to production. And this is how the config source is defined. You just have two cases, production and staging. And Sorcery, what Sorcery does, it generates from this the data parsing from the server and all the UI required to override this locally. So it builds all of that boilerplate, which is a couple hundred lines of code. So you can go into beta settings in our application, and even if you're assigned to production, you can just go, no, I want to be in staging. So this is extremely easy because we have many teams and we run a lot of tests. So rather than having to modify multiple files, you just add a variable and you just create an enum for the variants, and you are done with it. And Sorcery can generate that. Another simple example that happens quite often in Swift projects is type erasure. So let's say I have a protocol with associated type, and I want to erase Pokemon type here. So Sorcery would read this code. There's a simple template, and it will generate a lot of boilerplate for you. This is useful when you want to put associated protocols into an array. I'm not going to go into details. This is all online. You can access those protocols. But there are a couple of very useful protocols bundled with Sorcery itself. Obviously, it started with equitable and hashing and enum cases and counts, which Apple now replicated more or less. But because Apple doesn't give you source annotations, it means that if you want something non-standard or if you want to skip a variable, it's impossible to use Apple implementation. You have to go back to maintaining it by hand, or you can use Sorcery and just add skip equality or add extra arguments. There are mock and lenses that we generate, which Apple doesn't give you, which is extremely useful when you do TDD. There are advanced codable extension, which means you can implement codable with complex objects. This is still using codable underneath, but it just gets rid of the boilerplate you normally have to do when you have a more complex server information. And it builds property level diffing, which is awesome. Linux main is commonly used by Apple, actually. Apple uses that a lot. And property level diffing basically means when you do TDD and you try to compare two objects, or even worse, if you try to compare an array or a sequence of objects, this is how Xcode tells you something is wrong. Very useful. Obviously, you can, in a second, you can see what's wrong in your test and you understand it. So when I did Sorcery, I did it all with TDD. And I didn't want to read this because this is a waste of my time and it makes no sense at all why this would be the case. So I took like 40 lines of code to write a template that goes from this to this. It basically generates, similarly how you have equality, it generates diffing on property levels. So this is actually comparing two arrays, and it tells you that the object at the 0 index has wrong property, and it gives it exact name, which is very convenient. Sorcery uses that in every single test, and it's really easy to integrate into your own project as well. The other thing is the auto-mockable, which is very popular. So for each function in your protocol, this will generate a function call to see whether that function was actually called. It will give you the arguments that the function received. You are able to provide a closure that will be called when the function is getting executed by your actual object, so you can have side effects, and you can return a value. So this is a very simple mocking. This should suffice in most situations, but if you need something more powerful, people are building tools on top of Sorcery. One of those tools is called SwiftMocky. If you ever use OssiMockito or other libraries in Objective-C that relied on runtime, you are probably familiar with the given verify API DSL. So they basically use Sorcery to generate that DSL in a type-safe manner for Swift. So they just run on top of all your protocols that you say you want to generate mocks for and give you this a little more complicated and nicer API. If you like to write a lot of tests and you prefer this over the simple implementation that Sorcery goes bundled with, this is really easy to integrate. The other project that I really like that builds on top of Sorcery is called ObjectBox. ObjectBox is a multi-platform storage implementation that is way faster than Realm. As far as last test I saw, like we're talking orders of magnitude faster. And it also creates a very nice query APIs for you. So you want to define an object in your project, you just do conform to entity and you specify the types. As you can see here, it's very simple. You have this generic called ID, which allows you to mark something as a primary key. And then you just declare normal variables like you would do without using ObjectBox ever. So strings and typical primitives. And from that, they use a custom fork of Sorcery that they are relying on, and they build a query language. And that query language allows you to find like every person that first name starts with Steve, for example. And this is very nice because there is no, you don't have to write all of this code. It just gives you nice API. Sorcery is free and available on GitHub. And if you want to learn how to write code, there is a lot of tutorials. This is a project that is not relying on me at all anymore. There's like more than 80 contributors. There have been like 60 or 70 releases. You can eliminate boilerplate, write once, test once. First off, the main reason for Sorcery to exist is to limit human mistakes. Humans are not very good and not very reliable and not very consistent. Automation is very consistent. If you define the algorithm once, it will always look the same way until you modify it. And that lowers the maintenance cost. So this is mostly an intro how to write templates. I don't believe that presentations are the best way to learn how to program anything, which is why I built a workshop. And you can access it at my GitHub at Sorcery Workshops, and there is a step-by-step wiki guide for writing multiple templates that explain in more detail how to create functions, how to build all of those templates. And it also has a GitHub commit history for each step. So if you ever get lost, you can just jump to that step and go from there, which should be very convenient. And if you don't trust me that Sorcery is something you should use, there's a lot of people that you can talk to. So I'm here to open to questions.
Thank you.